Hello, everybody. My name is Stephen Feuerstein, developer advocate for Oracle Database. You probably know that I focus on PL SQL. That's pretty much the only thing I know. Fortunately, I know my limits too, so I like to have other people from around the world who are also experts in PL SQL share their expertise with you. And I've come to use the office hours platform as a way to do that. So today we're going to take a look at tips for analyzing PL SQL code from Shashank Barky, Shashank. Who has joined us twice before. Is that right? This is your third time?
Second time.
Oh, this is only your second time. Okay.
Yes.
Boy, do I lose count easily. Well, it's great to have you back. And so let's see, I'll share my screen, just bring up a little bit of information about Shashank because he might be have too much humility to go into it himself, but he's been working in Oracle Database for 13 years, developer, cloud architect, data analyst. In each of his jobs, he's always talked with people and the other developers about how to make the most use of PL SQL and use it most intelligently to end up with applications that work fast, are easy to maintain, and provide high security to the users. So I'm really pleased to have Shashank back. And what I'm going to do now is go away and start listening. So let's see. I'm going to stop my share. I'm going to turn off my camera, turn off my mic. But one other comment, so that you can enter text in the chat, but if you have a question, please click on the Q&A box at the bottom, and that way I and Shashank will be able to answer it, everybody will be able to see it, and also comment on those answers. All right, Shashank, take it away.
Sure. I am sharing my screen. Let me know if you're able to see.
We can see it. Okay.
Good morning, good evening, in whichever time zone. Those who have joined, welcome to Office Hours. It's very exciting to interact with Stephen and work with fellow community, whoever is promoting and using PL SQL in general as part of your day-to-day job. It's very exciting to share insights, share what you know, and try to learn from fellow folks. Right? This is an excellent opportunity. First of all, I would like to thank Stephen for getting me back. So let me get started. Very brief introduction. I work, like Stephen said, for a company called Manhattan Associates. Currently, I'm working as a kind of cloud architect, data analyst kind of role. But my entire career has been dealing with SQL, PL SQL primarily, and that is one area which kind of keeps me kind of going all the time, because there is so many things to explore and it's so advanced actually, right? It's like a lot of people would have just seen at high level stored procedures and triggers and thinking like maybe this is about stored procedure, this is about PL SQL. But believe me, once you start exploring and getting into the depth of it, there are a lot of things which are very exciting, interesting. And there has been a lot of improvements in last, I would say 6 to 8 years. From 12 onwards, there have been a lot of exciting features, and I would encourage everyone to go and look at all the documentation, the latest trends which are available with PL SQL. I can assure you, you will enjoy this, and this is one of the best programming languages you can kind of be using in your day-to-day job. Without much delay, let me talk about the agenda. So today, right, like when we were thinking about what we can talk about today, was one of the things which every developer, or if you are a business analyst or someone who looks at the code, right? So this is one topic which talks about how we will go about analyzing the PL SQL code as a whole, right? Like, because there are so many things, you would have written multiple stored procedures or maybe packages, and you would sometimes be working with code which you have inherited from someone, right? Like it might be passed on to you from your fellow teammates or people who worked on this kind of modules earlier. So what are all the kind of tips and kind of things you can keep in mind, which you can use as part of your arsenal, right? Coding or development arsenal, which is going to give you a lot of head start and like very good hold about the entire code. We'll look at certain things, certain tips, and believe me, once you start using them, you will really start appreciating this more. So the agenda today I have is to talk about code composition at a high level, how we can track the code, right? This is something which is exciting. And then you can you can even learn something about propagating exceptions. So exception handlers we know, or is it only SQL error M and SQL code? This was back, I think, when we started our career and all, know about 10 years back. We used to write SQL error message, SQL code, and just try to get those exceptions. There are other things also which you can explore there. So that's what we are going to see. And we'll even look at something called as DBMS metadata. I assume you would have probably come across this. This is also an exciting package which we have. Along with that, we look at PL SQL scope. So I'll tell you what that is. So how you can kind of use that to break an stored procedure or a package and get more useful information out of it. So, and again, like I said, this is the agenda is mainly to deep dive and try to understand the PL SQL code as a whole. And try to see what we can kind of get out of all these available packages. Especially if I am sure that like most of you are working with versions above 12c, so all the features which we discuss are available, and some of them are there even in 11 also. But yeah, so just this is a very small one. Like if you are a developer, you recognize all these things immediately, right? So what does a typical stored procedure or a package which you would have written consist of? Mainly, it's all about variables, what you declare, what are the parameters, does it have any in-out parameters, reference cursors, hey, what about iterations, okay, loops, then number of executions, how many times you are calling that, what about subprograms, is it like stored procedure which is calling another set of stored procedures, you have bulk operations, and like I said again, one more is the nested calls. So this is how usually PL SQL code is kind of composed of, right? Various structures, I would call it as. So now this is not what we are actually looking at and talking about what is a parameter or what is iteration. I'm sure you would have probably explored that. So now this is something we are going one level deeper, I would say. What exactly you can use when it comes to okay, when it comes to tracking, are you aware of certain features which give you a lot of information about the stored procedure or the code you have in general? And these are all some kind of I would say underrated dictionary views, right? Like most of you probably might have used few of these, but if I go back and look at the developers I have worked with, some of the things they have not even explored. So I thought that was a strange thing, considering these are available from some time, and they are very helpful. Believe me, like the kind of information you can get from this are really very useful. So we will look at these dictionary views specifically as the first starting point. User arguments, user objects, user source. I'll explain what these do. So I wanted to keep this particular session with some demos, right? Right away, I didn't want to present a thing for 20 minutes and go and give another 15 minutes demo. I thought it will be interesting to do it hand in hand. We'll talk about a concept and we will get into the demo immediately, so that now you get to understand what we're talking about. So let me share open my PL SQL, SQL developer. Okay. Okay, so start with, I have a sample stored procedure. I would call it as you can think of this as a dummy kind of an example stored procedure, right? Where you have certain information like the number of marks, percentage you want to calculate. It's something probably you can think like you have, you're, let's say, part of an exam, and this particular stored procedure will tell how much marks or how much points you have got out of this particular exam. So what are all the inputs you give for this are, it's very simple, number of correct answers and number of wrong answers. So, and you pass in user information. So, I mean, to give another example, let's think of it as election results, right? That's the flavor of the season. So you can think of, you pass on the user, in this case, let's say a presidential candidate, and you say this is the number of correct votes he has got and the number of votes he has not got. So it's like kind of comparison of like what he has got, and there is a one catch here. So that negative, there is negative mark concept. So this is just like a kind of an to make it little more interesting, where you pass, let's say, one correct vote gives you 4 points, and one vote which somebody ticks against you, you lose 2 points, something like that. It's a simple stored procedure. So we will be using this stored procedure to probably go through all the examples and various concepts which we'll discuss today. So let me compile this. I will be sharing these things, so you don't need to worry. As part of at the end of the session, we'll be sharing these things, so you can always refer, and it will be step by step whatever we are looking at. So this particular stored procedure, let me at a high level show that it has few returns some value. It's as simple as that. No, it's like no complications here. You can look at it as kind of there is even a call to one of the local stored procedures here. So it finally returns like how many points one particular user has earned. Like I said, it's +4 if you are passing, and if you are passing something like, let's say, 10,3 for a user, it goes calculates this value and gives how much is the total points he has. You can even think of this as something like a GMAT or CAT kind of score, right? Like or GRE kind of score, where it gives you some kind of points. So this is a dummy stored procedure. So let me compile that. Okay. So now this stored procedure will act as basis for us for all the things we are going to see. So now first thing we were looking at, like I said, was something called as tracking code, and to use various dictionaries which are available for us. So I will go through each and every one very quickly. So we have something called user arguments. I don't know like how many of you have used this, no? So this is an excellent option we have, where it will give you set of arguments you have. So you here I don't even know the stored procedure, right? I just compile, and just imagine using something like this for a big stored procedure. It can show all the kind of input parameters, their data types, whether it's in or out parameter. So all this information is available with user arguments dictionary, right? So then we have something called as user objects. User objects probably you might have used, I assume, because this is relatively very common kind of one which is used across. But again, this gives information whether it is valid, whether it is having what is the kind of object type, what is the object ID, and stuff like that. And the one you probably might have not used but is very helpful is something called as user object size. So this one, right, like if you were to see here, this is helpful to get information regarding the source size, the parse size, what is the error size, what is the code size. So you get information about how this particular stored procedure, what is the kind of bytes it is parsing, what is the kind of error information it is having, right? So if you look at this gives again all this information, which is very beneficial if you ask me, especially if you have a scenario, right, where you are looking at issues which usually deal with memory. Sometimes, no, like your PL/SQL procedure might be causing out of memory issues also, because it might be leaking and there could be some really bad code. So if you want to go back and debug these kind of scenarios, you can always look at user object size. And then you have something called as user source. This again, I suppose you would have used. This is also a very common one. This gives the entire output for me. It will give me not output. When I say output, it's the entire source code of the procedure. It gives the entire stored procedures source code starting from beginning. Just remember there is no termination here, that slash what you see. So probably if you were to generate this kind of using user source for various triggers or stored procedures, back in the day when we were not having tools like SQL Developer to directly extract, probably we were going and using these kind of scenarios. But just remember that you will not get the terminator here. So that is one more useful one. And then there is something called as User procedures. Yeah, user procedures is again one more which gives information about, like, there are few things which this talks about in specific. That is like kind of subprogram properties. It says like what is the subprogram information you have over here, and it is also very helpful if you ask me, because it even gives information like whether it's a kind of a parallel stored procedure, is it something which has been kind of defined in a different namespace, and things like that. So again, these are all the things we can utilize, and this is pretty advanced. And we have one more called as user dependencies. This really, believe me, is very helpful, because just imagine, you have a code and you want to know what are all the things which are referred over here. So you can even think of a scenario where you have written the code and you are using certain things like calling the sys kind of owner, right? Like there could be references to sys, there could be references to public as owner, something like what you have as like things like DBMS output. What are all these things? What are all the kind of dependencies you have? So this gives me all information about a stored procedure as a whole, even without looking at the code, right? That is the beauty of it. User source, like I said, will give you even the code information, but all others give plenty of information, but all these are without even looking at or opening the code. So just imagine getting information like, hey, what is the kind of size this particular stored procedure is kind of holding in memory? Is there any scope to make it better? Hey, could there be any possible memory leaks because of bad code? Or does it, I want to generate all the dependencies for this stored procedure. So these are all some of the things which you can right away use. And these are all user, so I'm not even used DB underscore or all underscore. So those flavor also are available. But since we are in the specific schema itself, we are not even talking about all underscore or DB underscore. I mean, I assume like you probably would have used this DB underscore once and all underscore views as well. So this is the first part. So now,
Shashank,
yeah.
one question that came up is, how is the error size used most often or most commonly? Have you ever used the error size information?
Yes, actually, what error size will be more of if in case there are some kind of stored procedure debugging errors, right? Like something like you have an error handler. Here, if you look at it, the code which we have, I don't think we have any error handler over there. Let me go back. This was like just plain stored procedure, right? It was not having any exception blocks or anything. So even that information gets captured over there in that error one. If you were to use some kind of exception block and all, that information also gets carried, and usually it's in bytes. Actually, that size is in bytes. Okay, so let me go on to the next one. So this is one more which is pretty interesting. So now let's talk about tracking code, right? Like, okay, now we talked about certain views which give us a lot of information. But if you ask me, hey, is there a way I can track the code, right? Like something like, can I get a information of like what are all nested, what is reference program and stuff like that. So here, if you are using 12, I think from 12, this utility started becoming more popular. There is something called as a format call stack. So this is an excellent utility. So I'm going to show you example right away. So we have two flavors here actually, DBMS utility call stack and utility call stack. So usually, format call stack doesn't give full drill down information. So we usually go for util call task, but you call stack. But in general, you can use either one. So this was actually introduced, I think, in 12 and above. Utility call stack. It even gives information with respect to error stack as well. So let me right away go to the demo to
and
talk
Shashank,
about that.
Sorry, just another quick question. Instead of querying the system tables like user underscore views, is there any simple stored procedure, I assume they mean pre-built into the database, to find the dependent objects for a table?
Dependent objects for a table or a stored procedure?
Yeah, so I think what Shanti is asking about is, essentially, I guess maybe I should answer the question. So the question seems to be, look, instead of having to write these queries, did we just provide an API, a PL SQL API that you could call, say, show all dependent procs? And the answer is no, we have not done that. I'll have to look around and see if anybody's published it. It's pretty simple stuff by and large. And I think Shashank will talk to you about PL scope, in which you get even more detailed information. But sorry, the bottom line is that certainly from Oracle itself, when you install the database, we give you the views and you go from there. Okay, there, I answered the question.
Yes, thanks, Steven. So I'll get into another demo. So this is about tracking code. So, okay. Just give me a second. Here, not to just provide a high-level example, I have created a set of stored procedures which are very self-explanatory and very simple, where we are primarily utilizing, like I said, format call stack. So this is the utility we are talking about. So this particular stored procedure, if you look at it, we have called it as SP1. We have made it very simple. So this will just print. It's like just a DBMS output, and it says this is what it is. It will just type. I think print few hyphens, about 25 hyphens. We are using RPad over there. So similarly, I have stored procedure 2 and I have stored procedure 3. So stored procedure 2 in turn calls stored procedure 1. So that is what we are trying to do here. And stored procedure 3 in turn calls stored procedure 2. This is like kind of a nested scenario. And at the end of it, we will try to call in an anonymous block, just stored procedure 3. So we will just see how we can get the information over here. I'll quickly compile this. These are very simple examples so that like you can go back and see how you can use it against your scenarios, right? Like you could have different use cases. It could be let's say 5-6 stored procedures part of a package. How you can utilize that, it's again, I will leave it to you, and you can definitely utilize these utilities for your use case as well. So if you look at it, so this is the stack I get. See, now what we did, we called stored procedure 3 directly over here, and we had, like I said, certain calls to other stored procedures, SP1 and SP2. And the call stack gives me the information. Hey, see, look at this. Now it says I have stored procedure SP1, which was the one which we had at the beginning, if you look at it. So it is doing the way it is getting called in an order. So SP3 is calling 2, SP2 is calling SP1, but actually speaking, if we didn't use this call stack utility, we would probably not be able to get this information, right? Like what was the stored procedure which got executed in beginning, or what was the one which got executed second. So that is the beauty of call stack. See, of course, you can say I can use DBMS output and all, but that is not what we are getting. We are getting the entire stack trace. It's like if you imagine like you have a scenario where there are multiple stored procedures which are getting called in a package, and you run this kind of utilities, it will give you more information on like the flow of the code itself. So that is the beauty of it. So this is a call stack concept. And mainly we are using something called as DBMS utility. This again is very vast. You can go and check. There are like a lot of options available. So here one which you can directly use is call stack. So this is about call stack. So this has another flavor.
Shashank, just real quick, we have a question from Phyllis. Is there a stored procedure that I can add that will help in debugging? I add lines that insert records into a table so I know which procedure or package I'm in.
Awesome. Yeah, we'll get to that. It's more of error handling stuff, Stephen. Definitely, we have some kind of concept to get that particular use case, which will help that particular use case. It's like kind of something called as tracking. So
tracing, yeah.
Fortunately, we have that as part of the session as well. So okay. When I go over there, we will look at that, and I hope that will help a person who has asked this question.
Perfect.
So right, no, yeah, okay. So now, like I said, this is one flavor. There is something called as utility as well. So utility stack. I didn't feel like I wanted to include that because it's pretty similar to this. So if you are interested, you can go back and refer to same scenario, util call stack. Instead of format call stack, it's a util call stack. So it gives more information, little more comprehensive information. But like I said, I will leave it to explore that part. So this is about call stack. Now let's go and look at propagating exception. So this is what we were looking at, right? Like I have a scenario where I want to know exactly the error information. So this is something probably you might be more interested as part of your development life cycle, right? So you all along, at least when I started as a PL SQL developer, we used to rely so heavily on SQL error message, SQL code. These were like kind of probably most important two important keywords, I would say, because you always wanted to capture. Then you do trim of that, substring of that, get that aura error out and all. So we have to kind of move on from there. So now there are better options available. So what we have to look at is something called as format error backtrace. This is also a part of DBMS utility. Like I said, DBMS utility is very vast. Believe me, it's again, if you want to just talk about it, like there are like too many things to discuss over there itself. But you have to like look at the use case you are or the problem you are trying to solve, and pick what is relevant to you. So one among them is format error backtrace. We are going to look at it. This again, like I said, it's self-explanatory. We'll directly jump into a demo so that you get to know what I'm talking about. So let me clear all this. Here, just to quickly walk through, like I have a stored procedure again on similar lines. Like I said, scoring, correct, wrong marks, or as part of, like I said, you can think of this as a election score or scorecard kind of thing. So here, what we are trying to do is to understand more about it. We are introducing exception as part of the code itself. So I wanted to, instead of relying on this particular thing to call some or create some kind of error, we are introducing exceptions, right? So you understand that user defined exceptions we can do with Pragma in it also we have. So what this particular thing is, it's just an extension of the code we saw earlier. It's nothing but same function which we saw over there, but here with it we are trying to raise exception which we have defined above, something like my exception or something, whatever it is, and I am trying to raise the exception. So that is what we are introducing as part of this code. And then we are doing same for the not stored procedure, local procedure, which we have over here. So what we'll do now, we will compile this again. Believe it's not the same name of the stored procedure, but the flavor, it's exactly similar. So let me compile this. Okay, so now let's look at what we were discussing about, that is format error backtrace. So this is a simple call to the stored procedure which I have. So stored procedure is compiled. So after stored procedure compilation, I even recommend you using show errors or something. That is one more useful one which will always tell what are all errors. Oh, thank God there are no errors here. So you always, as developers, you can probably start doing this kind of small, what you say, as part of your process itself. If you were to add show errors, that will be great. Of course, you can go back to user objects and see, like we saw. This is a live example. We can see user objects. Where object underscore name equal to.
I mean user errors?
Yes, we will try that also. So you get that it is procedure, it's valid, right? So then we will get the not the error. Where is that guy? Okay, user object size. Okay. Okay, error size is still showing 0. We have exceptions. So probably we can try to do one thing. Can we try to make this as an invalid stored procedure and see something like what happens? Because I mean, I have used this, but it's for some reason I am not able to replicate exactly. What I'll try to do is I'll try to compile a stored procedure which will be error prone, and let's see whether that gets compiled. Yeah, so error compiler log, it show errors I don't want. Now let's look at this. Yeah, here we go. This is what it shows. Now, if in case it has some syntax errors, it has given 450. That is like
So you can not only look for invalid status, you could look for error size greater than 0.
Absolutely. Error set greater than 0 will probably even give that information right away. So, okay, so I'll just go back and try to recompile this. Okay, so we are good here. So now what we'll do to understand error stack, we are going to call the stored procedure. Like I said, no, these are two parameters, sample parameters. You can think of this as a number of correct answers and number of incorrect answers. So like I said, if in case it's correct answer, it is doing something like into 4. Like it's like it's more of getting something like you are adding 4 points if it's correct, and you are deducting 2 points if it's incorrect. So something like you can think of this as, if I were to call this, it will be like 10 into 4 minus 3 into 2, something like it. That's how it is designed. It's very simple example. So now we will do look at this now. So now it is giving me the error stack information. So if you ask me what is this error stack information, so if you go back and see, we had introduced some exceptions, like I said. So we had introduced some exceptions, and it even gives the line numbers, like something like 32. It's a 19. Like what is 19? Okay, it says rise. Rise is one of the exception we have created. So this error stack gave us that information. Like, hey, go back and see. That is where you have some information over there. And then even there is an 23. I can see a rise here again. So it goes back and gives me information on that particular exception also. So this is like tracking exceptions. Now look at the advantage you can get from here. If you ask me, what are the things we are using to get through here, right? It's just this particular utility. So this particular utility we are creating in one exception at the end of the stored procedure, and it is doing something called as back tracing. Just imagine, like you're debugging the entire stored procedure. You are using something which can backtrace data for you and tell you what are all the kind of errors you have. So that is the beauty. Here I'm not even looking at SQL code or SQL error message. If in case you have used it, you would probably be more appreciating that these kind of options are available now. Right? I think this was available in 11 also, if I recall. But
right.
You can definitely use that, right? Yeah.
It was added in 10G release 2, in fact. And I have a question for you, Shashank.
Yeah.
Is there a way to create, quote, corporate custom, unquote, exception numbers, basically application specific exception numbers that are initialized across the whole database instance automatically, similar to the way that a handful of built-in Oracle standard named exceptions are already there and initialized?
So you meant to say all these 20,000 or kind of exceptions we have, you want to define something as a standard exception as part of the code?
As a named exception, right? Those aren't named.
Right, yeah.
Well, you do name them. So here, I think I can make this easy because obviously we don't have a lot of time here. I think I know the answer. So the answer, Justin, is that you can do what we, Oracle do. So there's a package in PL SQL called the standard package, and it has a number of pragma exception statements, pragma exception inits, and it does exactly what you see in Shashank's code. It declares an exception like no data found, and then it associates that no data found exception with the number. In this case, actually 100, not even negative 1403, but that's a whole little story by itself. And that is automatically available across the entire instance because the standard package is available across the entire instance. For you to do the same thing, you would create a package, let's call it, app. You would do all your exception declarations, your pragma exception inits for all your numbers, and then you would grant execute on that package to public. Now and then you probably create a synonym so they don't have to put schema.package name. And you'll essentially have a lot of the same flavor in place. But those are the steps you would go through. Back to you, Shashank.
Yeah, thanks, Ivan. So, like I said, this is something you can utilize as part of your development lifecycle. But I highly encourage, if in case you haven't used utilities track, DBMS utility format error backtrace, please start using this. This is going to help you, believe me. So this is about error kind of handling. Now let's quickly look at something called as user identifiers. So this is one more thing, right? Like I said, you would have information about the literals. You understand what are delimiters, comments. These are all the kind of things a typical stored procedure program consists of. So now you can think of identifiers as some things which are declared, right? Like these are all identifiers. These are all declared. It could be cursor, it could be constants. It could be even variables. So now with this information, so you want to kind of get more details about the kind of identifiers which are there in code. If you want to analyze more about that, then you have utilities available for that also. So there is an excellent dictionary view which is called as user identifiers. So let's look at that and let's see what data it gives. So after that, we will look at something called as PL scope tool. I'll quickly talk about that and we'll look at demo together for these two. So you can look at PL scope tool. I think again, if I recall, maybe Stephen can correct me if I'm wrong. Probably it came in 11 itself. PL SQL PL scope tool. It's more to do with kind of giving you information about the particular program compilation. Something like, there is something called as sysocs table space. I think you guys are aware of these things, right? So that is where it will be storing. It's like kind of more of the information about stored procedure itself. Where is the code? What kind of data? What is the kind of namespace you have? And all those things are stored over in sysocs. So you have to have sysocs table space for this particular thing. And all by default, I think all Oracle databases will come with this, right? So you don't need to worry. So you can run this PL scope tool from SQL developer. That's the beauty. So you get information on the user identifiers. Only thing we need to do, right? There is something called as identifiers all. This is nothing but it's something which we have to do for a stored procedure. At the stored procedure level, we have to run an alter command, because usually this parameter will be set to none unless we kind of explicitly set it. It will still be it would be by default none. So let me show you what exactly I was talking about. So this is how you set it. Something like alter session. System itself is not even needed. You can say alter session and set PL scope settings. You can give identifiers equal to all. And then to look at more about this, there is something called as $V parameter. I think you are definitely aware of it. So we have this particular dictionary view, all parameters kind of thing, which in this scenario we have anyway set it to all. But in general, it's going to be set to none. So what we need to do is we'll have to run some command to just set it for the stored procedure level. So if I were to run this, it's going to tell me about sysocs occupants. Like I said, this is something which, these are all the things which are available in that sysocs. So it gives you information on what is the schema, which obviously sys, right? Sysocs will be in sys schema, and it says it's about, I think, 2 MB or so. I think this can be even increased. This comes as a default 2 MB, but most cases it should be sufficing. But if in case there is a need, you can always increase that size as well. So it's as simple as setting this parameter. You need to just say alter procedure name, compile, and settings equal to identifiers all. That's all we need to do. And once you are done with it, you have to use a simple query. Right, like this particular query. Let me clean this. So if you look at this, so what this particular query is doing is, let me close this compiler log. Yeah, okay. Yeah, so what we are trying to do here, we are using user identifiers, like I said. So user identifiers is the dictionary we are talking about here. And we are looking at stored procedure which we created in the beginning. So like I said, this is a dummy stored procedure we have created, and we'll see what information we get from here. Look at this now. So this particular stored procedure data, how well we have got. Look at it. Like it says, hey, line number 1, you have procedure definition. Line number 2, you have, what is this, formal in, right? Like it's kind of breaking the stored procedure and telling what are all the things happening at a level where it is telling, hey, this is a varchar, and this is a particular variable you have, and then you say it's a declaration, and then say it's a data reference type is number. So it is like, drilling down the entire code for you. It's like, just imagine, getting the entire code broken into fragments. Like this is the beauty, like it gives you the in-depth information about the entire set of identifiers. So like I said, if you want to know what is the identifiers are, like I said, variables, constants, cursors, whatever you have declared in the code. So if you look at it, even it says like there is a function here, there is a function call made. If you remember the stored procedure definition which we had, so it had something like it had a stored procedure. In the stored procedure, we had called a local function. We had called a local procedure to just return us some values for calculation. So this particular one, it even gives information that there is a call to the function, right? So there is a call to a stored procedure, and it says there is a number which is a line. L_num is some kind of a variable we had created here, right? Some kind of number. So it even gives that information as a reference variable. So this is really useful, believe me, if you want to kind of look at an unknown stored procedure. Like this is one challenge we have, no, as development teams, right? Like sometimes you are not you are supposed to kind of support code which you have not written. So in these scenarios, you can always depend on these kind of dictionary views where you can get the entire set of information. So next thing, right, after this I was looking whether we can kind of have a dependency kind of a graph. That is one thing I am trying to explore. Maybe if Steven is aware, he can give some tips on it, like something like if there are like a user dependency thing, right? Like if there are 5 stored procedures, can we get it in a kind of a not a UI, I would say, some kind of a graphical view. That is one thing I am still trying to explore. If I were to get some information, I'll definitely add it along with these slides. Whether we can kind of visualize this particular code and say, hey, this is how this particular stored procedure is further broken down. So that is one thing, right? Yeah.
That sounds great. I don't have a quick answer for that one.
Yes, Steven, this is clear, right? Like what we can achieve from PL SQL tool. When I say PL, I always tell PL SQL. PL scope tool. Yes, I think we'll go to the next one. This is about metadata, right? So, hey, metadata is something which is as old as Oracle 9.9. So, when I started developing, as a developer in PL SQL and SQL, I think Oracle 9 had just come out of, we had started using 10G. That's how it was. Early versions of 10, but a lot of the databases were still in 9.9. Even then, I remember that DBMS metadata was available back in the day, but it has undergone some changes. This is very helpful to extract a lot of information. So this is about kind of getting information about the entire table definition. It's like more of now we have tools which does these kind of heavy lifting for us, be it SQL Developer or other tools like PL SQL Developer or a Toad, which also kind of gives you that kind of an API where you can right click and extract the entire code. But if you don't want to go, you are a conventional, either conventional DBA or developer who believes in the SQL and what Oracle packages are available to do these things. No, you have to rely on things which are available, and they are very helpful. Like DBMS metadata is really a very powerful package, I would say. So here it's something which I think by default, I would say you would have access to that as part of, as long as you are kind of having that catalog role. where you can access all the dictionary views. So let's get into that demo. Okay, as a sample thing, no, I ended up creating a table. I mean, I did not create any specific table. This is a table you would have probably referred multiple times. If you're a developer, you have used EMP and DPT tables, right? In Scott schema. So this is something which is really helpful. But again, I just dropped those and recreated the tables. So what I'll do is I'll try to extract the code from these particular tables. So now what I have done, I'm just getting DBMS metadata, get DDL, and I am passing the table. And I am giving the table name, which is nothing but EMP. So if you want to know the entire table definition, look at this whole. This has like whole lot of information, right? Like it says what are all the columns in the tables. It provides information on the storage, table space, maybe the indexes, foreign keys, primary keys, whatnot. So this is like, this gives comprehensive information. Now, hey, you can always come back and ask, no, hey, I don't want all the details over here. I want a trimmed information. No, usually this is how things work. So we try to get only what we need from the entire definition. So there are ways to do this, right? So this is the first step. So what we need to do is we have something called as transform handle. This is also a very excellent feature. When I was exploring more on this, no, like I found like there are like a lot of things which we can kind of ask the dictionary not to send us back. Hey, if I say I am not really worried how these particular table spaces are defined for the table, I really do not want table space information. I don't want to get like what is the size byte keyword. I don't want to get what are all the foreign key constraints involved with the table. I just want a table definition. So if you ask me, there are a lot of options available, and then there is something called as even the formatting side of it. No, there is something called as pretty there. I mean, expect you guys to explore more on this. This is also very useful. So we will run this and look at how it changes. So what I'll do before I run, let me try to copy this somewhere so that we'll be able to appreciate what information we got from here. Okay, so this is how the table definition is looking at when I used the exact one. So now I'm going to run this transform param handles. It's just a kind of a setting. So okay, this is done. Now we again go back and try to run the same command. Okay, here we go. So look at this now. So what data we got? So it's just giving me the tables, columns which are there in the table, and it's just telling the information about the primary key. That's it. Because we have kind of masked a lot of things over there. See now this is, if you ask me like whether we need to use these things, answer is no. Of course, we would want to get the foreign key constraint information as well. Maybe what we can do is rather there are certain things which we are not really worried about, like storage, right? Storage is one we are not really worried because this is something which is coming as extra information for us. So you can always just ignore that here itself. No, instead of storage false, you can always use storage. Then you can probably even SQL terminator is there. So I think this is something for what was the SQL terminator option? SQL terminator, I think, is not double quote. Maybe it is got to do with this compress, no logging, this kind of information. So you can always choose what we want, right? In some scenarios like this byte size keyword, if you look at it, if there are varchar and all, sometimes it may show something like varchar 29 of byte or char, right? So that also you can kind of mask if you don't want to even have that information printed for you. So this is something like I said, which will just transform the output for us, but they are very useful. So you can explore more on this. These are all some of the things which I chose, but you can explore a little bit more. Even you can even get the code for the entire procedure or package, or maybe even for an example, even the index, right? So if you want to get index information alone, so if I run this, see, it's giving me only the index code. It's not giving me table space because I think we masked it, but it just gives me the index definition here alone. So, and even I think if you want to explore further, I think there are options to even mask this, what is that called, schema name as well. This is also available. I've used it. You can explore this more also. You can just get the information like create unique index in the index name on table of column name. That's it. That kind of information also you can get. So that it's so powerful. And metadata, right? Like I said, it's just we have just probably looked at the tip of the iceberg here. It's very vast. And I remember, like when these tools were not available, we used to generate the code for entire set of stored procedures. I remember that. So even entire set of tables trying to get using metadata and get DDL, it's very powerful. That also is possible. So this is more about it actually. So there are some references. So there are a few links I have provided. You can the best place to always start with is Oracle documentation, right? So nothing beats Oracle documentation, let me tell you. And there are some good options available. Even you can refer Advanced PL SQL Guide book also. It's very excellent. With that, presentation wise, I am done. Maybe if you want to discuss anything specific, we can. Stephen?
Nice job, Shashank. You covered a lot of material. We got a number of positive comments along the way. Here's a question. Does this DBMS metadata, does it always have 3 in parameters?
I mean, again, I think so. I remember running with these 3. But again, you can explore. Maybe
Yes.
there are certain in parameters which are mandatory there, because it's table name, and schema name is usually what we use. Because I have not gone and tried whether you can omit username and run and stuff like that actually. But that's something which you can explore.
And why don't you stop sharing?
Yeah, sure.
So we can see your face really big in the recording. So,
Okay.
and one point I wanted to make just on your response, I think was really good to the question about DBMS metadata, which is try it yourself. We're not magicians.
Yes.
So for example, people will constantly send me questions or post a question on Twitter, does X and Y do this, or how do I make it do that? And what I generally, unless I've already written a script to show that, I sit down and I write code and I go exploring. And this is, of course, what you did in preparation for this talk and your previous talk. So the point being, I just want to put out to our audience is that if you have a question about the technology, ask away. But the best way to get an answer to your question is for you to actually write code and explore, because then you'll learn, then you'll internalize what the physical writing of the code will drive the lessons into your head much more effectively than listening to me or Shashank or anyone else. So don't hesitate to just try to answer the question even before you ask it, and then ask if you can't get to an answer. Okay.
Yes.
Any other questions? We have a number of thank yous coming in, but let's see if we've got any questions. All is quiet, quiet, quiet. Okay. All right. Looks like we're done with questions. Shashank, thank you so much. You came in right on time. We will publish the recording probably in the next couple of days. We'll also make sure that you have access to the code that Shashank has written and anything else that relates to this presentation. So thanks everybody, and stay safe. Have a good day. Have a good rest of this year, I hope. And I'm pretty sure that 2021 is going to be at least a little bit better. Hopefully a lot better, but I'll take even a little bit better. All right, everybody, take care. Happy PL SQL coding. And again, thanks, Shashank, for your time and your expertise.
Thanks, everyone. Yeah, bye-bye.